Hi, welcome to Alibaba Cloud Academy for Clouder Certification course. In this course, we're going to introduce you about the ApsaraDB for ClickHouse, which is a high-performance real-time analysis database service on Alibaba Cloud. So we break this entire course into 5 parts. At the first part, we're going to introduce you what is the ClickHouse and also its background and some features about the column-oriented database. And to the second part, we're going to show you like the ApsaraDB for ClickHouse, so which is the Alibaba Cloud version of ClickHouse. We will show you some like enhancement that we do, and also what's the difference between the ApsaraDB ClickHouse open source version of ClickHouse. And at the third part, we're going to show you some like use cases and scenarios, which case that we could use ClickHouse to help enhance your business. And at the first part, we're going to help you understand like what was the difference between ClickHouse to other OLAP products, so like AnalyticDB. And at the end, we are going to show you some like interesting demo to help you see what's the performance that ClickHouse can do. To help you get better understand about the ClickHouse and especially for its feature, we are going to briefly introduce you about the ClickHouse background. So it was developed by Yandex, which is the most popular and also the largest search engine in Russia. And to help analyze its user traffic, Yandex developed a online traffic analysis tools, which is called Index Metrica, to do a series of like data analysis based on the collected data. So for example, like the click events and also the click flows, click streaming in Yandex on each page are collected to analysis in ClickHouse. And the Yandex Metrica is for all-around web analytics. So from the traffic chain, like to mouse movement, it will help you to get like a comprehensive understanding of its online audience and drive business growth. So it allows users like to process data and also visualize data by different segments. So ClickHouse was born in production in Yandex over a decade ago, as we mentioned before. It has also become a de facto standard inside the index for advertising systems and also for monitoring and observing data, and also in the business intelligence, recommendation platform, OLAP, and even for car telemetry. So it has a outstanding data processing speed, which is about 100 to thousands faster than the traditional approaches. And for example, it could process 20 trillion rows of data in total in Yandex, and 90% of queries has a second level response. And ClickHouse released to open source in 2016. So the name ClickHouse comes from the combination of data warehouse and clickstream. And ClickHouse is a open source distributed column-oriented OLAP DBMS for real-time data analytics using SQL. That's its official definition. So as we can see that in the DB engine rankings, ClickHouse demonstrated an outstanding performance and a notable growth in GitHub community. So we could see like right now it has about 20,000 of stars. And in this year, so it's 2021 September, ClickHouse officially announced to incorporation. And also in the October, it announced have the 250 million in funding, raising the company's valuation to 2 billion. So ClickHouse performance exceeds comparable column-oriented database management systems that are available on the market. It processes hundreds of millions to over 1 billion rows and tens of gigabytes of data per server, like per seconds. So as we mentioned before, the ClickHouse works 100 to thousands faster than traditional approaches. So to compare ClickHouse with other products, we have to mention about like Vertica. So Vertica is a massive parallel processing data warehouse platform that's designed to work with big data. The ClickHouse is 3.56 times faster than Vertica. Also a well-known Greenplum, the ClickHouse has over 9 times faster than Greenplum X2. And it's way faster than the traditional database management systems. So for example, like it has 177 times faster than Hive. and over 500 times faster than MySQL. So we could see that's the magic of ClickHouse. And to get understand about the technology behind it, we need to learn what is the column-oriented database management systems first. We need to get understand like how the column-oriented database store the data. As the diagram shows that we have a row-based table. At the right-hand side is the column-based table. So for a row-based table like MySQL and other traditional approach, we can see that we store each rows in a individual chunks. So for example, like in each chunk, it includes the row ID, the date time, the material, and customer name and quantity, right? But however, in column-based, it stores each columns in individual chunk. So in the column-based stores, we could see that in first chunk is all about the row ID, and the second chunk is all about the date times. So right now you can understand about the storage, and let's see what's the difference between the queries. When we do the queries, what's the difference? So we could see there's two GIF could show. If we are doing the queries based on the row-oriented database, right? We need to scan the entire table, like one by one, and to get out the columns that we are required. However, if we are doing the query based on the column-oriented, we only need to scan the columns that we are required for, and if the columns match the rows, it will extract the data. So it's super fast based on its mechanisms. And that's the reason why that columnar database is a preferred choice for analytical application, because it allows to have many columns in table just in case, but do not need to pay the cost for unused columns on read query execution time. And the column databases are designed for big data processing and also for the data warehousing. And to get deep understanding about the ClickHouse performance and how the column-oriented structure helps to achieve that, learning the detailed feature will be very helpful. So firstly, process data under column-oriented structures just as the GIF that we showed before. Only the required columns are read. And compared to the row-based database structures, it could save a lot of disk I/O. And just for example, if you need like 5 columns out of 100, you could expect a 20-fold reduction in I/O compared to the row-based database. And secondly, so since the data type in a column is the same, right? It could gain better compression rates. And besides, there are multiple compression algorithms that are available for the developers to choose, and it works best for the certain data type to maximize the compression rate and gain the better performance. And the thirdly is the vector computation engine also plays an important role in boosting the CPU efficiency. And also, we should notice that ClickHouse is a database management system. It's not a single database. So which means if you want to like create a database, load data, and query in runtime, you don't need to like rebooting the server or change the configuration of the server. You just directly apply to it. ClickHouse is designed to work on regular hard drives, so which means that cost per gigabyte of storage is pretty low. But if SSD and or additional RAM are also fully used if it is available. Let's check the SQL structure of ClickHouse. As the MySQL, ClickHouse also uses the declarative language to define the table structure, and actually it is highly compatible with SQL. So it supports create table like MySQL did. And also it allows the general statement like order by and simple by. But different from MySQL, it allows users to select a engine that based on the table and script. I will introduce the engine later. And it also support partition to split data, so generally by datetime. For ClickHouse, you could define the primary key and the index granularity. But the primary key in ClickHouse are not like the primary key in MySQL. Actually, in ClickHouse, the primary key is a very important and distinctive feature should be learned. The primary key of ClickHouse is not distinct value in table. So in other words, it could be replicated primary keys in a single table, which means that in ClickHouse, primary key cannot be used to do like remove duplicate rows. So if you want to do so, for deduplication, the merge tree table engine can help. And the reason behind the replicated primary key design, as we mentioned before, the compression rate of ClickHouse data is incredibly low because of the data is compressed in column. The same data type perform a better compressed efficiency. With the primary key, the data physically sorted and it make extracting data for specific values or range with very low latency, which is a very common scenario in OLAP. And when apply the where condition in ClickHouse with primary key, the indexes can directly locate to the corresponding index granularity to avoid scanning the entire table. And the default value of granularity in ClickHouse is 8192. You could modify the value based on how you distributed your data with primary key to achieve the extreme performance. And for ClickHouse usage scenarios, it's mainly about the large-scale data storage and query. To improve the performance of data processing, it supports flexible sharding strategies to utilize the power of massive parallel processing capability of cluster to boost like query execution even faster. So here we categorize the sharding strategies into 4 kinds to help you get better understand. The first one is the random sharding. So as the name delivered, is very basic approach to do the sharding. Data randomly assigned to distributed cluster nodes. And to consider the constant sharding, it assigns data constantly to specific nodes. And the last 2 sharding methods, so the difference is the column value sharding shards the data by hash value of column. And the customized sharding allows the user to pick a expression to calculate the hash value and do the sharding. Last but not least, sharding nesting structure and sharding mechanism helps ClickHouse to perform linear scalability in horizontal to build large-scale distributed cluster and having the ability to handle gigabyte of data. So let's take a look about the table engine. The table engine plays a critical part in ClickHouse. It determines the data storage and rating and the support for concurrent read and write, index, the types of queries, and the host backup replication. So ClickHouse provides about 32 table engines for different scenarios, but there are 4 series in total. So there are log family, merge tree family, integration, and special. So for example, like log family is for small table data analysis, and merge tree family is for big volume data analysis, and integration is for external data integration. Also, you need to know is there is also a replication data engine called replicated and distributed table engine called distributed could be merged with logtree or merge tree family. And new users may feel very confused because of all of the choices. So we're going to dive deep in each. The first table engine that we need to learn is the most universal and functional table engine in ClickHouse. It is the default choice called merge tree family. So merge tree fits good for high-load tasks that deliver the core of ClickHouse data storage capabilities. It usually applies to big volume data analysis, and it allows the quick data insertion with subsequent background data processing. Supports data replication with replicated prefix engine and partitioning and secondary data skipping indexes, and also the storage ordering and so on. So besides as previously introduced, ClickHouse does not support the data duplication by using the primary key, right? So to implement the deduplication, we can use replacing merge tree engine to do so. And secondly, we come to integration. So as the name indicated, it used to import external data or execute operations on external data. It supports Kafka, MySQL, and so on. Next, coming to the log family. So we should say lightweight engine with minimal function. It's designed to mainly read and write data very quickly to a small tables. So the small table that we are talking about in here means the table that containing about like 1 million rows. And here are a few characteristics that worth to mention in log family. So first, data is appended to disks in sequence for quick write. Update and index features is not supported with log. And to avoid conflict, the insert operation will going to block the selection operation in log. And the last group is special, so it contains all the customized engine for specific scenarios, like memory to store data in memory, and it's good for store the temporary tables and processing. Also, like non-engine could help and empty the written data. There are also other like specific engines like buffer or set memory buffer for the target table or files to store local files as data. When you encounter a very specific problems, so you may go to the special engine to explore the solution. Besides, there are 6 features that are good to learn for a better understanding about the ClickHouse. So first of all, as the SQL structure that we introduced before, ClickHouse is highly compatible with SQL. Actually, in official document, the description is that ClickHouse supports the declarative query language based on SQL. So it could support like group by, order by, join, and so on. Secondly, the data replication and integrity are also very important feature in OLAP database. ClickHouse uses asynchronization multi-master replication, identical data on different replicas. And recovery after most failure is performed automatically or semi-automatically in complex cases. Turn to the third one, which I think is a very interesting and impressive feature about ClickHouse, is the as I introduced in very beginning, at the starting point, ClickHouse was designed for high query performance to support the clickstream data analysis of the index. So in the product design stage, they sacrifice some functions to reach the strategic goal, which is for the extreme processing speed with incredible amount of data. The approximated calculation is a very good example to do so. Think about in the index usage scenarios, is always used to analyze the user clickstream and make the user portrait to push matched advertisement and links. It doesn't require like very strict accuracy as the bank transaction system do, but the time efficiency is always the key to win the customers. So we could understand that how it could help in the scenarios. And actually, ClickHouse provides various ways to trade accuracy for performance. It supports aggregate functions for approximated calculation of the number of distinctive values, median, and quantiles. It also provides options for like running query on partial data to get a approximated like simple result. Last but not least, to run a aggregation for a limited table of random keys instead of all keys. Under certain conditions for key distribution in this data, it could provide a reasonable accurate result when using fewer resources. The real-time data updates and online queries, which make ClickHouse different from many other OLAP, As you may know that many OLAP database management systems do not aim for online query with sub-second latency. But because ClickHouse supports table with a primary key, it can quickly perform queries on range of the primary key, and the data is sorted incrementally using the merge tree. Due to this, the data can continuously be added to the table. No logs are taken when new data is ingested. For the last two features, they are about the resource management capability of ClickHouse, handle the large queries, and taking all the necessary resources available on the current server. Secondly is distributed processing on multiple servers, which is also a very distinctive feature in ClickHouse, since almost none of the column-oriented DBMS mentioned have supported for distributed query processing. So data can reside on different shards. Each shard can be a group of replicas used for fault tolerance. And all shards are used to run a query in parallel and transparent to users. After we get over through all the critical features and concepts about ClickHouse, let's summarize to the usage scenarios about the ClickHouse. So first of all, it can be deployed on containers like Kubernetes, and it works well on the bare metal and of course on the cloud, especially on Alibaba Cloud as well. Here are some key properties of OLAP scenarios. So there are usually a vast majority of requests are read access, and data is updated in fairly large batches, like more than thousands rows. But data should be added in data table with barely update or delete. Another very typical feature in user click analysis. Image that is fairly records every actions that no need to update or delete. And for reads, the white table, which means the table contains many columns, and quite large amount of rows for specific columns are extracted. It will bring the benefits of low storage cost, high compression rate, and also the low latency for queries. For example, query latencies around 50 milliseconds are allowed. And remember what we talked about in the beginning. So there are 90% of index queries are respond in second level. Besides, it also supports large table aggregation with many columns, so like log analysis. And also worth to notice that it works under the low concurrency query, which is about 100 queries per second. On the other hand, it is easy to see that OLAP scenario is very different from other popular scenarios like OLTP or key value access. So it doesn't make sense to try to use ClickHouse in typical OLTP scenarios like transaction. And also, if we try to use Mongo or Redis for analytics, we will get very poor performance compared to OLAP databases. Also, the cons about the ClickHouse is that it doesn't support complex big table drawing. So imagine if you have multiple complex systems and you would like to put those big tables together for analysis. You should not directly try to use the ClickHouse to do the analysis. The solution could be aggregated multiple tables into a wide one and then process the query by using ClickHouse or use Alibaba Cloud Analytics DB to solve the issue directly. And thanks for watching. For more information about ClickHouse basic concept, you could always find it in ClickHouse official website and documentation, or explore our analysis about ClickHouse via Alibaba Cloud Tech blog. In the next session, we are going to introduce the specific features and enhancements that ApsaraDB for ClickHouse made.